8.5 and 8.6, we are going to focus on graphing exponential growth and decay functions. And like we talked about functions that get larger with an exponent, then those are growth, and if they get smaller, then those are decay, like when we were talking about word problems, if your money grows or are you losing value. But graphically, if you look at the growth function, as you read a book, we would read from left to right. So from left to right, if it goes up, then that's going to be growth. But if it goes down, that's going to be decay. So if you notice, this number is greater than 1, so that's growth. This number is less than 1, so that is decay. If you were to reflect these graphs over the x-axis, it would look something like this and something like this. So these are still both growth functions. The dotted one is just reflected. These are still both decay functions, but the bottom one is just reflected. So let's take a look at some graphs. Graph A is growth, because from left to right it is going up. And now let's look at graph B. Is it reflected? No. And then it says, how does it shift? So from graph A to graph B, where did it move to? Well, if you look at graph A, the y-intercept is 1, but graph B, the y-intercept is 3. So if you compare the point 1 to the point 3, it looks as if we have shifted up 2. If you also shift your x-axis up 2, it would be right here, and that shows you that this now matches your original graph, so you know that your shift is correct. Okay, example number 2. Again, we have a growth function starting with a y-intercept of 1, and if you look here on the graph B, we have a y-intercept of 4. So it looks as if it has shifted up 3. But if we shift our x-axis up 3, the pictures do not match. So that means that we do not shift up. So we'll figure out how else we can shift. Well, if we look at where the point 0, 1 shifted to, we can actually see that it shifted left 2, and this is not reflected. If you shifted your y-axis left 2, this would now be the point 0, 1, and your graphs would then match. Example number 3. This one is a decay function because it's going down from left to right. We are also going to look at the point positive 1, and where does that go to? Okay, but if you look at graph B, is it reflected? Yes, this graph has actually flipped. And if you look at the first page of your notes, anytime the graph was not reflected, it had a y-intercept on the parent graph of positive 1. But when they were reflected, they had a y-intercept of negative 1. So let's take a look and see where that y-intercept of negative 1 shifts to. Because this is reflected, we're going to compare the point negative 1 instead of positive 1. And it looks that we have shifted up 3 units. If you shift your x-axis up 3 units as well, you can check to see if your answer is correct. Would this point now be negative 1? Yes. Okay, so let's take a look at this graphing by hand without shifts, just using a table. You know that you can use an XY chart just plugging in values of x and getting values of y in return. So if we look at the function y equals 2 to the power of x, and we plug in some numbers, we can plot those points and get an idea of the shape of this graph. I'm going to start with 0. If you plug in 0, you get 2 to the power of 0, and we know that anything to the power of 0 is 1. If I plug in 1, I get 2 to the first power, which is itself 2. And if I plug in 2, I get 2 squared is 4. And if I plug in 3, 2 cubed is actually 8, because 2 times 2 times 2 is 8. So now let's explore what a negative exponent does. Let's plug in negative 1. 2 to the negative 1 would actually have to flip to 2 to the positive 1 over 2 to the positive 1, or 1/2. And 2 to the negative 2 also flips because of the negative exponent. So we have 1 over 2 squared, which is 1 over 4. So what happens is it takes all of these values that we've already found and just flips them. So if we flip this, we get 1 over 8. So let's plot these. We've got 3, 8, 2, 4, 1, 2, 0, 1. And then when we go in negative territory, we have negative 1 up 1/2. So that's just between 0 and 1. And then negative 2 up 1/4, so that's up even less. So just estimate. And then draw a smooth curve from left to right. Now notice, when we plugged in positive values or negative values, we got positive y values. That's because there's no exponent that you can plug in that's going to give you a negative answer. A negative exponent just simply flips your answer. So, will this graph ever go in negative territory? No, not without a shift. Okay, so this is clearly a growth function. So let's look at a decay function. Now, how did I know it was decay? Because this 1/2 is less than 1. So let's go ahead and plug in some values. Let's plug in negative 3. If I have a negative exponent that I put on that negative 1 and on the 2, it actually flips both of those, so I have 2 cubed over 1 cubed. And we know that 2 cubed is 8, 1 cubed is 1, so we just have 8. Likewise, if we plug in a negative 2, it flips both of those, and we end up with 4. So if you notice, it's taking what we just did in the first example and flipping all of those answers. Still, anything to the power of 0 is 1. Anything to the power of 1 is itself. And we shall plot negative 3 to the 8th, or I'm sorry, negative 3, 8, negative 2, 4, negative 1, 2, 0, 1. And if you notice, from left to right we are now going down. And again, we're not going to go in negative territory unless there's a shift, and when we're graphing by hand, we are not going to do any shifts. The next two problems you would do the exact same way with the XY chart, only you are raising it to the power of 3. So like if I plugged in a positive 3, 3 cubed is 3 times 3 times 3, which is 27, but a negative 3 would flip that. So now negative 3 would have the 27. So you can complete those tables.